Hi there. So in this video, I just want to talk to you about nesting your parts before you send over files to us. We get sent all sorts of files, some nested, some not. Not a problem. We can do it on our end, but it will save you money and time if you're able to send over files that are already nested. So I thought I'd do a quick video to talk through about how best to do that, and the kinds of things to watch out for. So this is a file from OpenDesk, which is an open source kind of platform. So they kind of specialize in sheet material that's cut on 3-axis CNCs. So it's a good kind of file setup to show you because they've really got it nailed down. So first off, you can see here we've got our 8x4 sheets laid out. Now what they've done is they've created an offset here. And that offset gives them a bounding box to work within. This is because we don't want our parts to be up really close next to the edge of our sheet. If our parts are right on the edge, it might mean they get missed off during cutting. We load the sheets on the machine as best we can, but we can't guarantee. So we normally say a minimum of 5 mil to the edge of sheet. Here, they've given us about 10 mil, which is nice and generous. It's a good way to do it, just having this offset, because it gives you a real visual cue to work towards. Now, the important thing to say with nesting is there's two things to consider, is large parts like these ones and small parts like these. Now, your parts are held down on the bed by vacuum pumps, which basically function down to the surface area of the part. If you've got a large surface area, it will hold really well. If you've got a small surface area like these ones, then it won't. So it's important with the parts that have a small surface area that you leave extra room around them. I'm going to show you why that is here. So in our programming, we basically, the cyan here represents our toolpath. We want there to be excess room around it, so we create a holding frame which we tab our part to. So if I show you the simulation, what we ideally want is something like this on these small parts, where this is your part, and these little yellow bits here, they represent tabs. Now the tabs are only 1 mil high, so they're very easy to break off and trim back after, but they just hold the part in place while machining so they don't fly around. Now, as you can see, we've tabbed to a holding frame around the part, and this means it's very strong and it's not likely to move. If our parts are too close to one another here, we're going to get a train where the tab joins to another tab, joins to another tab. Now that's fine for a couple of rows, but for a large section like this, it's always stronger to have a frame around it. It means your parts won't move, we won't lose them during machining, and you're going to get everything that you sent over to us. Now, the other main thing with nesting as well is how close your large parts are to one another. Now, that partly depends on what tool diameter and tool you're designing to. These here has been designed to fit let's have a look, an 8 mil tool. So in general, we'd say leave 9 mil, right, between parts minimum. Always add a mil on extra, depending on what tool you're going to use. Often we'll cut half a mil away from your part, and then we'll come in for the final pass to give you a real clean, crisp edge. So we need that extra room to play around with. That's a very quick overview of nesting, which I hope will be helpful. And if you do have any other questions, you can always send them over in emails. All right, thanks for listening.